Thank you very much. It is my great pleasure to be here once again in Buenos Aires. And many times I've been to Argentina, and I've celebrated free software with you. My talk today is a very special talk because this is a very special year. It is 50 years since 1969. And in 1969, there were a lot of very interesting things happen. Number one, people walked on the moon. And the entire planet came to a halt that day as people ran to television sets around the world to see this most amazing thing. People were joined around the world by this concept of people walking on a different body in space. Somewhat less important, but still important, was Woodstock, a giant music festival in the United States that set the tone for music for the next few decades. In 1969, in New York City, there was a riot at a place called the Stonewall Inn, where trans people were being bullied and hurt, and gay people and people of different types of diversity were being persecuted by the police. And they caused a riot which started the beginning of the LGBTQ community and movement in the United States. In a small laboratory in Bell Labs in New Jersey, two people started a small operating system just for fun. They didn't think it was going to be important. They were just trying to do research in new operating system ideas. And we'll see a little bit more about that in this talk. The ARPANET was funded, which eventually became the internet. And people never dreamed that the internet would be what it is today. In fact, the address space of the original ARPANET was only 15 bits. So it couldn't have very many nodes. In Helsinki, Finland, little noticed by anybody except his parents, Linus Torvalds was born. Yes, Linus is 50 years old this year, which makes me feel incredibly old. In 1969, I was a university student, like a lot of you. I was studying electrical engineering, and half of my degree was in business administration. I was almost electrocuted by 13,600 volts and 800 amps, which kind of guided me towards software and programming. Finally, in 1969, it was the last year I ever shaved. Now, you would notice a little asterisk beside that, which indicates throughout my talk that there's another story behind that. But we don't have time for all those stories. But the more asterisks there are, the longer and sometimes better the story is. And if you get me out with beer, sometimes I'll tell them to you. So we're going to go back to the beginning, not the very beginning of computer science, but when I started programming. And computers were physically huge. I worked for a company called Aetna Life and Casualty, and they were the largest commercial user of IBM equipment in the free world, which goes to show if you put enough adjectives around you, you could be the best of anything. I am the handsomest man with a long white beard and hair standing on this stage at this podium. See, I'm the best. But computers were also logically very small. They would have maybe 4,000 bytes of memory, and they would work with devices that would read and write data at 5 characters, 5 bytes per second. This were measured in megabytes, not gigabytes or terabytes like we do today. And the programs were run one at a time on the computer, even if the computer was a mainframe. And even if it cost $2.5 million, the programs were run one at a time. And a lot of these computers had switches and lights on the front of them because you could use those switches and lights to debug your program, because your program was the only thing that was running. And if there was an operating system, it was incredibly primitive by today's standards. It was typically specialized in doing one type of thing. Maybe it would run a batch job on cards, or maybe if you were really lucky, you had a time-sharing system that you could have terminals attached to. There were computers that were dedicated to real-time processes. And there's a rumor, and it's still a thought pattern today, that companies created different operating systems because they were trying to lock their customers into their hardware. They were trying to get their customers to write to that operating system because that would tie that customer to their equipment. Now, if this was true, then the digital PDP-11 computer system that was very popular in the day would only need to have one operating system. But instead, we had 11 different operating systems. Because what we were trying to do was make that piece of hardware be more efficient in running our customers' programs. And so we wrote the operating system to do specialized tasks. We had an operating system for doing health style of work, and an operating system for doing educational style of work, and an operating system for doing real-time style of work, and so forth and so on. We actually had 2 different Unix systems running on our PDP-11. And if we were just trying to lock our customers into buying our equipment, we would need only one. Now, also back in those days, most of the code that was distributed in source code form. There wasn't enough of one type of computer to really justify creating a binary code and manufacturing it like cookie cutters. And so if you ordered a compiler, you might spend $100,000 for that compiler. And you might negotiate with the company for several months with your lawyers talking to their lawyers about how many systems could you put that compiler on and how many people could use it at one time. And in the end, you ended up with the source code for that compiler. You kept that in your vault or in your lawyer's vault, because what happens if that little company that you bought it from goes out of business? There were also very few professional programmers. There weren't people who really wrote programs for other people to use. And if you were a programmer, it was because you were also a physicist and you needed the program to do your work. You were an electrical engineer and you needed the program to do your work. You were an educator and you needed the program to do your work. In fact, I had a professor at the university, Drexel, who said to me, "John, you'll never be able to earn a living being a professional programmer." And I'm still waiting to see if he was right. There were also no software copyrights or patents. You could not copyright software. You could not patent software. The way you protected your software was through contract law, making one of these contracts and getting people to sign it. And this required much money and many lawyers even before you touched the software. And there was also many points of sharing. There were vendors groups like DECUS for the Digital Equipment Users Society, Share for IBM, Brainstorm for Novell, where people who wrote these programs would contribute their programs in source code form to people to use. And why did they do this? Why did they sell their software? Well, quite frankly, selling software is hard work. You have to guarantee bug fixes to your software. You have to write documentation for your software. You have to distribute your software, all these different things. And the people that wrote this software were not in the business of selling software. They were physicists and engineers and educators. So they gave away their software to other people who they thought could use it. And sometimes these people would meet them at these meetings like Deacon's and say, "Oh, you wrote that great software I'm using. Thank you very much. It's very helpful. I have some ideas to how to make it better." Or, "Gee, you wrote that software that really saved my life. Let me buy you a beer." Or, "You did a really great job. Let me buy you dinner." Or, "You did a really great job. Let me give you a job." And a lot of these reasons are the same reasons that people write free software today. They write it because they need it for themselves, and they write it because they can demonstrate their programming skills and a lot of times get a job or generate a service out of writing it. Now, I've described the computing industry in 1969, but this one guy named Ken Thompson had been working on a project called Multics that was a combination of different companies coming together and trying to create a be-all, end-all operating system called Multics. And eventually Ken Thompson was taken off of this project and brought back to Bell Labs in New Jersey. And he was very upset about this because he liked working on operating systems. And he met up with this other man named Dennis Ritchie, and together they started to create this little operating system that they called Unix, because Multics was everything for everybody, and Unix was one thing for one person. And they started by saying, well, instead of putting all the functionality in the center of the computing system, called the kernel, let's make the kernel very small and have it do some things very well. And then all the other things that people need will move outside of the kernel into these things called libraries. And this made it easier to get that kernel to be correct. Now, the first couple of kernels were written in the ones and zeros of machine language. But after a while, Dennis Ritchie said, boy, this is really difficult. I'm going to invent this language called C, and we'll rewrite the kernel in C, and then it'll be much more portable to the next system we bring it to. And they kept working on this to make it more and more portable. Now, this was a strange thing in those days, because computers were so expensive that who cares if you have to train your person to use a different operating system to be more efficient for running your program, because the machine was worth more than the people were. And Dennis and Ken had this idea that people were actually more expensive than the machines were. And as the cost of the machines started to drop, this became more and more true, that it became easier and easier to buy a new machine with the same operating system on it and the same commands and the same libraries, maybe a different machine architecture, but that was hidden from you by the operating system. And people found out that I can use the same programs and the same command, whether the machine comes from Hewlett-Packard or IBM or Compaq or any number of other companies that are no longer in existence. And at first, this operating system was distributed in source code form. And this allowed universities to participate and bring in good ideas into this, a collaborative effort. And Ken and Dennis would bring in some ideas and toss away others and things like that. They were the architects of the system. But despite the fact that a lot of people think that Unix was free, it was never free. It was always owned by AT&T, and sometimes it was barely even open, because only universities that were research universities could get the code for a reasonable price, $350 US, to put the code on all of the computers at your university. If you were a small 2-year technical college, like the one I taught at, you had to get a different license. And that license was $160,000 US per CPU. And you had to tell somebody at the telephone company the serial number of the computer you were putting it on. Now, how many of you have ever tried to call somebody at the telephone company? It's like trying to call somebody at Google. Do you know in the 150 million pages that Google is in charge of, web pages, there's not a single telephone number? You can't call people at Google. You can barely send them email. So this concept that Unix was free and open was a myth. And remember, these guys were creating this operating system just for fun. They were researchers. They didn't mean to sell this or anything. They just wanted people to use it. And other contributions from Unix systems was a small command interpreter, which we call the shell. It still exists today, even in Linux. A lot of you use the shell, you call it bash. Well, this shell was called the Bourne shell. It was written by a man named Steve Bourne. And it was simply SH. Later on, there was another shell written that extended that at the University of California, Berkeley, and it used the C syntax, so it was called CSH. And then another shell was written by a man named Dave Corn. It extended that, and it was called the Corn shell, KSH, and so forth and so on. Eventually, the Free Software Foundation wrote the shell over again, making it free software. And they called it the Born Again shell, bash, which a lot of you use today. But this was a new concept. Normally, all of this functionality was in the kernel of the operating system, which made the kernel bigger and more complex and more likely to fail. One of the great features of Unix and the Unix command line is something called pipes and filters, which allows you to take the output from one command and feed it into the input of the next command. This was another new concept, and it was so new that the person who invented it, named Doug McElroy, had to actually write some of the first Unix commands to show Ken Thompson and Dennis Ritchie how this worked. Things like portable network file systems came from Unix, and a client-server windowing system was developed at MIT for Unix systems. And there were many more very radical ideas that came out of the Unix marketplace. Now, all of these Unix systems were being developed by universities, and the universities would pass around the source code, but the source code was still very expensive. If you were a company, you'd had to pay $160,000. And so what happened in 1962 was a little company called Sun Microsystems had formulated a small computer that was built and designed at Stanford University. And they said, we want to have a powerful operating system on top of this little computer. MS-DOS was too weak and miserable for this system. CP/M, another operating system of the day, was only good for 16 bits of address space, 65,000 bytes of memory. So both of these were just too weak. Sun actually came to my company, Digital Equipment Corporation, and said, we want to take one of your operating systems, but that was impossible. So they decided to use the University of California, Berkeley's version of Unix, which is called BSD. And they wanted to go to the telephone company and say, can we have a better license, a cheaper license for this? And the telephone company said, okay, if you distribute Unix only in binary form, not the source code. You can sell it for $350 per machine, and you do not have to tell us what the serial number is. And Sun Microsystems said, wonderful, we'll do that. Now you have to remember that even though this was a small desktop computer, it was still selling for $15,000 back in 1982. That's about half the price that my parents paid for their house. A 3-bedroom house with brick. It had a living room, a dining room, a family room, a 2-car garage, 1/4 acre of land. They paid $32,000 for it. So this workstation that sat on your desk and allowed you to do work was half the price of their house. But people still paid it because it allowed them to do amazing work. And they put this Unix license on top. Now, other companies like Digital Equipment Corporation and Hewlett-Packard and IBM saw the business model, and they too started to bring out their own versions of Unix, also in binary-only form, not in the source code. But most of them utilized the code from the University of California, Berkeley. And the reason for that is that the AT&T code, called System 5, was a swapping type of operating system. It meant that you had to have your entire program in memory at one time. The Berkeley system used something called demand page virtual memory, which meant you only had to have a certain portion of your program in memory at one time. This was more desirable. System 5 only had 2 compilers that came with it, C and Fortran 77. The Berkeley code had 3 compilers. They added Pascal. But the most important thing was that the System 5 networking was a dial-up networking called Unix to Unix copy, where your computer system would actually dial up over the telephone lines, make a connection to the next system, and pass the data on. And the Berkeley system had implemented TCP/IP. Remember TCP/IP? It came from the internet that was started in 1969. But one thing that the University of California did not have, that System 5 did, was a big marketing budget. And so for the next 10 years, every week in the middle of this big computer magazine, AT&T would have an advertisement for System 5, the right choice. But nevertheless, they still lost. Now, there was one person who objected to this binary-only copy of Unix. He was a student at MIT in Boston, and he decided that he liked seeing the source code for these operating systems. It was worthwhile having it. It made it easier to maintain the operating system. His name, of course, was Richard Stallman. And he announced this project called GNU, a project to completely rewrite all of Unix in source code and make it freely available. And the first piece of code he wrote was Emacs, a text editor. Now, Emacs is so complex that most people say he could have stopped with Emacs and he would have had his complete operating system. But he went on to do other programs that were useful to programmers, and these programs would work on different operating systems. So you could use Emacs on MVS and VMS and Unix systems and so forth. And all of a sudden, programmers got the idea, got the information that, yes, I only have to learn my text editor one time, and I can use it on all these other different systems. And the next thing he did was write some compilers that worked on all these different systems. And people started to say, well, I can write my code the same way on all these systems, and the only thing I have to watch out for are the system calls to the actual operating system itself. And he started to gather more and more people that saw this vision. And in 1985, he created the Free Software Foundation, which I bear the brand on this shoulder. Now, he kept doing this, first the Emacs, and then the compiler suite, and then various utilities. And people began to understand that this was allowing people to be portable across these different operating systems. And this also allowed some small companies to start up, giving support to this software that was written by the Free Software Foundation. Some of them simply gathered up the source code and put them onto CD-ROMs and sold the CD-ROMs. Other people actually printed books about how to use this software, and O'Reilly is one of the major book manufacturers that did that. And some companies, like a company called Cygnus, actually supplied support to major corporations like Boeing to use these compilers on different systems. They did some work specifically paid for by these companies that the Free Software Foundation didn't have access to the machines or the people to do it. And so people started realizing that you can make money by supporting free software. Now, the company I worked for, Digital Equipment Corporation, we had been supporting Unix from the telephone company, from Bell Labs, on our DEC hardware. But we were mostly writing device drivers and things like that. And I joined Digital in 1983. I'm going to stop here for a moment, and I realize that most of you were not born at that time. Some of you, your fathers were not born at that time. But I joined in 1983, and we were bringing out a Unix system based on 4.1 Berkeley software distribution. We brought out two of them. One of them was a 16-bit system called Ultrix 11, and one was a 32-bit system called Ultrix 32. Now, this started these Unix wars as different vendors started to see that there was this market that could be satisfied with Unix. Mostly it was a scientific and technical market, and software development market, and educational market. That was about 16% of the marketplace. The other 84% of the marketplace was what we call commercial software, which is represented by banks and commerce and things like that. That was still in the mainframe and batch and proprietary operating system area. Databases were also, in that area, and those typically ran on commercial systems. So there were two groups that formed. One was called Unix System Labs, which was made up of Sun Microsystems and AT&T that joined together. And Sun did a very stupid thing. They decided to abandon the code from the University of California, Berkeley, and instead support the code from System 5 of Bell Laboratories. This was a decision made by upper management for political reasons, and the engineers looked at the code from AT&T and said, this is terrible. And so the very first release of their new code base was called Slowlaris, because it was so slow compared to Sun OS, their BSD base. Eventually, they did the optimization to bring it up to speed. The other companies like DEC, IBM, and others formed a group called the Open Software Foundation. And what they did was create a set of standard programming interfaces and a test suite and a set of standards to say, if you can pass these standards, then you can call yourself Unix. This was a radical idea because it meant that you could implement an operating system using any code base you wanted to, as long as the programming interfaces stayed the same. And it also meant that the most important thing was the brand of the product, Unix. It allowed people to know what they were getting. Now, this started some wars, companies vying back and forth, and eventually, in 1991, Unix System Labs sued a tiny little company called BSDI and said, "You're using AT&T code without paying royalties to the telephone company." And BSDI said, no, the code that we get is all from the University of California, Berkeley. And the telephone company said, no, there's still some, a telephone code in there. And this dragged on for years. And this stopped people from moving forward with the BSD code as a solution to a free operating system. Eventually, the BSDI people and the University of California, Berkeley got rid of all of the AT&T code. At that point, they created a distribution called BSD Lite. That became the basis of certain operating systems that still exist today in the open source space: NetBSD, FreeBSD, and OpenBSD. But that was 1994. In 1991, there was a student named Linus Torvalds at the University of Helsinki. And he had gotten a brand new 386 computer for Christmas. And the 386 computer had a facility to it, a feature to it, that no other Intel system had before. And that system, that feature, was to be able to run demand page virtual memory. Remember the importance of that from where Unix came from years before. Linus knew that his system had that capability, but the operating system that came with it from a company named Microsoft did not take advantage of that feature, because Microsoft was still supporting the customers using the 186 and the 286 that did not have this feature. So Linus decided he was going to write a kernel that used this feature, and this would be his operating system. He was writing it for himself, just for fun. And he sent out a message over the internet, and he said, "I'm writing this operating system just for fun. It's not going to be as big and powerful as Minix." And people started joining him with that and giving their expertise and their time to help to generate this kernel, which would then be the core of the operating system that some people call GNU Linux. Now, why could this happen at this time? Why at this time? Why not before? Why not after? It's because there were these cheap, powerful computers, and the 386 was not new in 1991. It was actually several years old. And people had older 386 computers lying around their house that they could say, "Oh, I can dedicate this computer to this Linux project." And there was also faster internet to the house, both dial-up and DSL and cable, which allowed people to do this work at home, not having to do the work at the university or doing the work at their employment. There was a lot of information online about how to build operating systems. There was the Minix model of building operating systems, and there were other toy or other operating systems that were done that people could see the techniques of using them. And in 1989, the World Wide Web had been invented and was now maturing to make it easier to transfer huge amounts of data with links to make this production easier. And Even porn was easier, in fact, because of the World Wide Web. So in 1994, which are 3 years after Linus started his kernel project, and 10 years after the GNU project was created, people brought together the Linux kernel and various parts of the Linux system to create the GNU Linux system. Now, at that time, system vendors, except for Sun, had given up the desktop computer to Microsoft. And Microsoft owned 90% of the desktop market, with Apple owning 7% and everything else owning 3%. Windows NT had been invented by Microsoft. It was not only used in some desktops, but also using server systems. And this was scaring the large vendors, because this is where they used Unix, and this is where they used their proprietary systems, and Microsoft was eating into that space. Tim O'Reilly had actually stopped producing books on Unix because he said it was a dying market. And he was actually producing books about Windows NT. I don't blame him. He had people that were working for him. He had to keep them with jobs. So I don't really blame him for deserting the Unix market. But in 1994, Linus had finished version 1.0 of the Linux kernel and had released it. Now, when you create operating systems, a version anything less than version 1 is still a heavily developing model. It's not really ready for everybody to use. Version 1 is a signal to people that this is an operating system that you can use. Now, I met Linus at a DECUS meeting in New Orleans in 1994. And the reason that New Orleans has 2 asterisks behind it is that there are 2 cities in the United States which are adult Disneylands. One of them is Las Vegas. The other is New Orleans. And I love New Orleans. And I met Linus and I saw Linux for the first time, and I sat down and I used Linux and I said, wow, this is really good. This is on a weak, miserable, crappy Intel computer chip. It isn't a VAX, it isn't an Alpha. This is one of these weak, miserable, crappy Intel chips, and this felt really good. It was really peppy. This was something really good. And I said to Linus, would you like to create a 64-bit version of Linux? Because the Alpha was a 64-bit computer. Why is that important? With 32 bits, you can access 4 billion bytes of data at one time. But with 64 bits, you can access 4 billion times 4 billion bytes of data. How much data is that? That will fill up a 1 gigabyte disk every second of the day, every day of the year, for the next 5,386 years. Or it will allow you to store 128 bytes of data for every square millimeter on the surface of the Earth, including all the oceans. It's a lot of data. And it allows him to support multiple processors, not just Intel and AMD, but Alpha and Motorola and ARM and all the rest that were coming. And he said yes, he'd be happy to do that. So I gave him a $30,000 computer system, and I got some engineers from Digital to help him, and then I began to understand the power of the free and open source community. The people who took their own money to go out and buy Alpha processors so they could help with this project of porting Linux to the 64-bit system. And in 9 months, we did a port where most of the people never met each other face to face. They only worked over the internet. And I had engineers at Digital who told me that this was impossible. And at that point, GNU Linux exploded. And it wasn't just GNU Linux, but it was software from all these different places came together, from MIT, from BSD, from Carnegie Mellon, from all these different places. But the operating system still had no real applications, no commercial applications. But what was happening was the World Wide Web. Remember that? And the World Wide Web needed server systems that had shells, and it had a web server, and it had email services, and all of these things were on Unix and now got ported to Linux. And it was on these weak, miserable, crappy, but cheap Intel systems that people started to put into place as routers, as firewalls. They started reusing old equipment that could no longer run Microsoft to do all these things at no additional expense. Several other things happened in rapid succession. 1994, where Beowulf supercomputers came into being. We'll talk more about those in a moment. In 1998, databases like Informix and Sybase and Oracle all ported to Unix systems, or the Linux systems. And that meant something to me because this was exactly the same set of procedures and steps that other operating systems took as they started to gain momentum. In the year 2000, embedded systems chose Linux as being the most used system for embedded system designs. Up until this point, embedded systems were specific operating systems written by people. But in the year 2000, customers started saying, we want our embedded systems to talk to the internet. Oh my God. That means they have to be secure. And they have to have a TCP/IP stack. Oh, that's difficult. Oh my God, what are we going to do? There's an operating system that already runs on all these processors. It already has a TCP/IP stack. It already is secure, and it's called Linux, and it's free. And overnight, people started using Linux for new embedded system designs. I mentioned supercomputers in 1994. Supercomputers were very expensive, but the companies that made them were dying. Companies like ECL, Cray, Control Data Corporation. And you would design one of these systems, and only 4 people would buy them. Sometimes they were a government agency that we dare not say their name. We dare not talk about the NSA. And a couple universities would take them, but universities never pay you for anything because they don't have any money. So you might actually sell one of them, and that just wasn't enough to keep you alive. So the companies were dying. And these 2 people, Donald Becker and Dr. Thomas Sterling, said, we need supercomputers because of one very, very special problem you may not even think about. It's a problem called fluid dynamics. You know, I tell people that math is behind everything. Math is behind physics, and physics is behind the real world. Well, fluid dynamics is the essence of math and physics. Fluid dynamics is everything. It is the air, it is the water, it's the currents in the water, it is the weather. It is this piece of wood. Maybe the wood is a solid, but the heat flow through this wood is fluid. And so this is a very hard problem to solve, very compute intensive. We used to build wind tunnels to test airplanes and to test cars for aerodynamics. They were very expensive to build. But you could simulate that if you had enough computing power, and you wouldn't have to build this very expensive wind tunnel. And so they said, we can take this gigantic, hard-to-solve problem and break it down into many, many tiny little problems, and instead of having a supercomputer do it, we'll use these weak, miserable, crappy Intel PCs to solve each tiny little problem and then bring the answers together. And they called this the Beowulf supercomputer. Now, this was developed in 1994 inadvertently. I met a young man in 1995 who was going to university. I said, here's a copy of Red Hat Linux. All you Red Hat people out there, I gave them Red Hat Linux. And overnight, all of the national laboratories in the United States used Red Hat Linux to build their Beowulf supercomputers. That is actually a copy of the young man I gave that CD to. His name is Pat Goda. And he's in front of a system called Loki, which Pat was using to simulate what would happen if meteors crashed into the Earth. Up until 2001, he was crashing them into New York City. After September the 11th, he chose Los Angeles. But he still went on, okay? And today, of the 500 fastest computers in the world, all of them run Linux. The same Linux that you run on your laptop or your desktop. Two of them used to run Microsoft because Microsoft paid them to run Microsoft. We can't have all 500 running Linux. Pay them to run Microsoft, but it got too expensive. They're still there, but they're like 572 out of the 500 fastest computers. You see there a prize, the Gordon Bell Prize. Gordon Bell works for the Microsoft Corporation in their supercomputer area. There's a prize named after him, given to the best supercomputer. It's never been won by Microsoft. I know Gordon, he's a great guy. So the next thing that happened was the years of the Unix desktop. And actually, I should say Linux desktop. But, Unix, we kept trying to get it onto the desktop. And people would not use Unix because they were too used to MS-DOS and Windows. I don't know if you remember this, but your parents, when you said use the computer system, they would write down in the notebook, hit this button, wait till the screen lights up, type in this name, type in this word, that's your password, and they would write this down in a notebook because that's the way they use computers. And that's one reason why people did not switch over to using Linux on the desktop, because they were too used to using computers that way from this one standard interface, or what they thought was standard, of Microsoft. Another reason for not using GNU Linux was the lack of games. Now, games is an interesting subject. Here in Argentina, you actually pirate about 84% of your desktop software. Yes, you laugh and clap. But what happens when it's your program that you have written and you are expecting to make money off of the software that you wrote? You're expecting to feed your family. You're expecting to be able to make your tuition to go to school. Is it so funny then? This is one reason why I, as a free software person, is adamant against software piracy. Because it takes money out of the mouths of people who expected to write that software and make money from it. Instead, you should be using truly free software written with the intent of giving it away and the intent of having you help make it better, a collaborative development model. But with games, it's even worse, because the piracy rate of games is 99%. The game company makes the one CD, and magically that CD is duplicated 50,000 times. Yeah, we bought the one copy. And this is why a lot of game companies are now giving away the game software and selling you plastic toys instead, or making you attached to a server and pay a subscription fee, because that's the only way that they can make money. This is why when people say to me, how do I make money with free software? I say to them, the very first thing you do is you write a business plan to make sure that after you've done the work of creating this free software, that you have a way of making money to keep the free software going. But the other reason why Linux doesn't really make it on a desktop is the fact that most people need only 5 applications. They really do. They need a desktop application, they need all this stuff, and they never get to that. I am told I'm out of time, so I'm going to skip ahead a little bit. Another threat is Apple, where Apple decided that computers weren't computers anymore, they were actually consumer items. They wanted you to buy an iPhone because it was fancy and because you could brag to your friends, not because it necessarily did anything you wanted it to do. But Android foiled Apple's plan, because remember, there used to be 90% Microsoft and 7% Apple. Microsoft took the philosophy, if you could even say the word Windows, you could put your software on their hardware. And Apple said, nobody will make money from us unless they're named Apple. Android screwed up Apple's plan, because Android is now the new Microsoft. If you could even say the word Android, you can have your application there. You can put Android on top of your hardware. So all these hardware vendors are creating different platforms for people to use. And now we have the cloud. The cloud is another way that these companies can trap people into using their facility. I come from this country called the United States. You may have heard of us. And the United States has this law called the Constitution, which protects my privacy against these agencies which I've mentioned. But you have no privacy in my country. You have no rights under my law. None. Zero. Zip. And so if your data even creeps across our borders or goes to certain places that are controlled by us, my country can look at your data with impunity. If I enter into the conversation, they have to stop because I'm a U.S. citizen. But as long as you're talking to yourselves, or you're talking to other people in other countries, they can listen and they can change your data if they want to. This is why it's important for you to make a way to store your most important data inside of your country. And you have to understand what happens when that data escapes. Your control you need. We have to take back the cloud from the large cloud vendors. I'm going to skip the summary of the history. What I'd like to do is talk about the future for a bit. We have users these days, people that don't know about computers, people that have never written a program, but they're using computers. We have to make them understand about freedom. We have to make them understand that the opposite of freedom is slavery. Companies tell you what to do, when to go, where to put the code, what you can do with it, when you have to retire it, when you have to upgrade. That is software slavery. And when you're a slave, you have no control. You have no control over your life. You're told when to marry, when to have children, when to die. You are a slave. And we don't want that because we are human beings. Some companies say they love open source. In the ancient Greek, there were 3 words for love. One was agape, the love of God for man, the love of mother for child. But even a mother's love is not without cost.
If you love me, you'll take out the garbage. If you love me, you'll feed the dog.
But it is the greatest of love. The second love is philos, brotherly love. From that we get philanthropy in Philadelphia and psychology. Philadelphia, the city of brotherly love, the love of you for your friends. Not quite agape. But then there's the third love, eros, the deepest, dirtiest love, the sexual love. We get erotic from that, erotica, sex. That is the love that some companies have for free software and open source. Do not bend over in the shower. We are very close to world domination. 60% of all the servers in the world run Linux. The 500 fastest computers in the world run Linux. Most embedded systems, your D-Link routers, your L-Sys routers, either run Linux or BSD. All of the major companies in the world run free software in some way, shape, or form. We just have to go a little bit further, and that's your job. Your job is to publicize free software, is to publicize why it's good, is to make people understand that with free software, they have control. I'm still working on a series of projects, but quite frankly, I'm 69. My brother retired at 55. Most people I know retired at 65. I've had 3 heart attacks. But I am working on a few projects like Caninus Lucus, which was showed down at the stand for these last 3 days. These are computers that we are designing and building in Brazil, and I'm here in Argentina to help you start designing the same type of computers here. I've made some good contacts. We're going to share ideas, and we're going to start building these computers in Latin America instead of sending billions and trillions of pesos to China. I have nothing against China. I have a lot of Chinese friends. But they make enough money. And I want to create jobs in Argentina, and I want to create jobs in Latin America. And there's things like Internet of Things, which are too dangerous to allow this to be done by people outside of your country. We need to have software freedom for them. Finally, thank you. I have one last retirement project, Maddog's Monastery and Marina of math, music, microcomputing, microbrewing, microwinery, microdistillery, and bait shop. Because if you have a marina, you need a bait shop. This is opening in 2025, and you're all welcome. And one last thought. People have been coming up to me the whole week and saying, thank you very much for coming to Argentina. Thank you for the work you do. But I tell you that if you want to see the most important person in free and open source software and hardware, when you get up tomorrow morning, you look in the mirror, because it's you. Thank you very much.
Tenemos tiempo para una pregunta. ¿Alguien? ¿No?